We're continuing our survey of the ethics of artificial intelligence by focusing on what I'm calling machine learning ethics. So, as always, we take our list of 5 values with us. If there's an issue that doesn't involve one of these 5 values, then it's not going to be about ethics, it's about something else. Right? So we're thinking about how one of these 5 fundamental values is implicated in different areas of artificial intelligence. And here are the 5 buckets that I've been working with. We start with data, almost always, because when you have artificial intelligence, you have algorithms that learn from examples. Now, if we're doing like reinforcement learning, those examples could be rewards and punishment. But in every other area, those examples are data. So we got to talk about data ethics. Ethics of prediction is about how algorithms show up in our lives in the real world. And then there's the ethics of AI personhood, which is about like futuristic kind of issues. Now, one thing that's different about those 3 than the ethics of machine learning and reinforcement learning is that you can actually go a very, very long way and say some very important things and make some important points and do some great analysis in those 3 areas, prediction, data, and personhood, without knowing very much at all about the underlying technology, how the machines actually become intelligent. It's just not necessary. Now, there might be like some specific things where it's helpful to have some technical knowledge, but mostly you don't really need that. I think that is not true when it comes to machine learning, right? So if you want to really make ethical insights, I think there's a lot of technical stuff you need to know about machine learning to really talk about ethics, which I think makes it one of the most exciting fields, at least to me. Anytime that you have a combination of the quantitative and qualitative, and you got to put those skills together, it's just so compelling and so interesting. If you like to geek out on both of those things, I think the ethics of machine learning might be your future. And just a quick note, I made this point in a few different videos, but reinforcement learning, of course, is traditionally considered a part of machine learning, and I consider it as well. But the issues in reinforcement learning are so fundamentally different because the examples that the algorithms learn from are not usually data. So when I talk about the ethics of machine learning, I'm focusing on supervised and unsupervised learning. You can think of reinforcement learning as part of that. That's great, no problem there. But when you're having the ethical conversation, it's just so different that you might as well just hold them separately. I found anyway. Okay, so when we talk about the ethics of machine learning, there's 2 sub-areas they're both really bulky and important areas. One is algorithmic bias, and the other is algorithmic accountability. Let's talk about bias first. So a bias, at the most fundamental, is simply a favor or a disfavor toward a person or a group, an idea, an outcome, a result. Basically, any noun can be the object of bias. But we haven't talked about yet what makes it unfair, because, of course, you have to favor an idea or a result to get through life. You have to favor one and disfavor others. If you weren't able to do that, then life couldn't happen really. So what makes it a bias unfair? It can't be that it's just a favor or a disfavor. What makes it unfair? What makes it unfair is specifically that favoring or disfavoring is made before all the relevant information is digested, or in machine learning terms, before all the relevant data is processed. Okay? So if you have a favor towards this, but there's data that you haven't processed yet, then we would call that a bias. And I would invite you to think about a really nice synonym, prejudice, right? So we learned when we were small children that prejudice is bad. Well, what's bad about it? Is it bad because it's judging? No, we make judgments all the time. We make dozens, probably hundreds, maybe thousands of judgments every day. Just tiny little judgments all the time. So judgments are not bad. But what makes it bad, what makes it prejudice, is pre-judging, judging before before all the relevant information is in. So we do that, we humans do that, and what we know is that's a big problem. What about machines? And here the machines in question specifically are algorithms. Can algorithms become biased? Well, let's back up like maybe a decade and think about like the early 2010s. People were really optimistic about algorithms that, look, humans are grumpy and they have bad experiences and they have hidden biases and they have, you know, context and stories and life, and they get grumpy and all these kinds of things that make them biased in all sorts of ways. Isn't it great that now we have algorithms that can do the thinking for us, because algorithms don't get hungry, they don't get grumpy, they don't have bad days, and they don't hate anybody based on gender or skin color or something like that. And so algorithms to the rescue, they're going to save us, right? Because they don't have bias. That is not a sustainable position. I mean, I can understand how there was one point, you know, in human history where people were like, oh gosh, human bias is such a big problem. Maybe algorithms can help us get away from that. A reasonable hope at one time. Turns out that's not at all true, okay? So algorithms, I'm not so worried about explicit bias. I mean, explicit bias in algorithms would be like if an evil scientist designed a system to, you know, to harm a particular group. That's not usually the case. The algorithmic bias that we need to worry about is a bias that is more or less equivalent of human implicit bias, right? So we know about human bias. There's generally considered two kinds. You have the explicit kind, where it's like I'm biased and I know it, and you know, but then like that kind you can deal with, or at least you can recognize and then try to deal with it. Where the implicit kind is harder. It's like everybody is filled with all these implicit biases in their brain, and it's just, you can't really just address them easily and say, hey bias, get out of my head. It's just kind of there. That second kind of bias that I talked about is the kind that I'm worried about with algorithms, okay? The kind of bias that just slips by undetected, but it's still there. Okay, so what we can't say are that algorithms are neutral and unbiased. That's not. But we could have a conversation about whether they're more biased than humans are, or less biased than humans are, or more to the point, actually, if we can, I'm still open to the conversation about whether the bias that algorithms do have is harder to address or easier to address than human bias, because of course we know that human bias is very hard to address. So for me, the jury's still out on that, but we can't say that humans are biased but algorithms aren't. Okay, I'm going to come back to that in just a minute here, but I want to switch gears for a second to talk about the second big bucket, accountability. So accountability is a great, rich word. It's just like someone taking responsibility for something, and implied in that is the opportunity to change it. In the context of algorithms, so again, we're talking about machine learning models. We're not talking about the data that the algorithms learned on to generate the models. We're not talking about the ethics of prediction, how the models show up in our lives. We're talking about the models themselves, right? So I would say one way to think about the opposite of an accountable model would be like a black box model. You've probably heard this term. So a black box, just imagine you're staring at this box and you have inputs, you know what the inputs are, and you have the outputs, you know what the outputs are, but how the inputs are connected to the outputs is just a complete mystery. We don't know. So in a practical sense, this would be like someone saying, applying for a loan, and okay, so now let's input all your data. Some calculations happened, and you're not approved for the loan. The algorithm, the machine learning model we have here says that you're a credit risk, so we're not going to give you the loan. Okay, so what's your question? Your question is, why? All right. What does the algorithm think it knows about me that it thinks I'm a credit risk? Can someone tell me? And I've never heard anybody say, oh, it'd be fine if we would just say no. Like, no, I have no idea. But the model said your credit risk, we don't know why or how it came to that conclusion, but it did. So sorry. I don't think there's very many of us who think that's an okay future. Or imagine if the machines we're talking about are like autonomous vehicles, right? So the autonomous vehicles, like, maybe they run over a few pedestrians and we're like, I wonder why it's doing that. Oh, well, there's no way to know. I guess the model just does what it does, and that's all there is to it. Nobody wants that future. We want accountability. We want to say, okay, there was an accident. Something happened that we don't like. So how can we get in there and figure out what it was? What is responsible for this problem, and how can we fix it, right? That's the idea of accountability. Okay, so we want accountability. We don't want black box models. We want accountable machine learning models. The first thing you might think is, okay, so we got to figure out how to get them. We got to figure out the technical resources and requirements necessary to create accountability. That is an important question, but I would suggest strongly that not be your first question. Before you ask the how question, you've got to ask the what question. What kind of explanation is worth having in this context? The thing about explanations are there are lots of things that can count as an explanation for one single event, right? So imagine that there's a glass here and knock it over, and then it hits the floor and shatters. So if I ask the question, how do you explain what happened? There are a lot of things that you could say that would be valid explanations. But depending on what kind of explanation we were wanting or expecting, some of those explanations are going to be completely useless to us. So we have to figure out what. I mean, so, in the case of the glass getting knocked over, we could talk about everything has an equal and opposite reaction. We could talk about the brittleness of the glass. We could talk about the chemical composition. We could talk about hand-eye coordination. We could talk about me having a bad day. We could talk about gravity. I mean, there's a whole bunch of things that would explain, that are valid explanations for the glass getting knocked over and shattering. But there's probably only a small subset of those explanations that are ones that we want, okay? So what I'm saying is, you might think you want to start with the how question, but that is not the place to start. You want to start with you want to ask the what question before, because that is going to guide your technical how examination. But that's not even the question to start with. I think there's a previous question. You actually want to start with the why question. What are you hoping to achieve here? What is the purpose of this accountability? Is it to make the algorithm safer? Is it to make it more fair? Is it to be able to manage it? Is it so we can generate trust? I mean, so there are a bunch of goals, and usually those goals end up being ethical. And so that's really how I connect the accountability conversation to ethics. Okay, so once you've got clear about what your goal is, like why you want the accountability, now you can start to think about, okay, so what kind of explanation is going to be helpful in this to help me achieve the goal that I have? And then you can ask the question of, okay, how do I technically create the kinds of explanations that are the kind that I want that will help me get the kind of accountability that I want? All right, so the final thing I want to do in this video is introduce you to this matrix. I came up with this. I mean, so I have it trademark or copyrighted down there. If there are things you disagree with because you're smarter than me, that's just fine. This is a kind of an evolving matrix. I add to it and subtract all the time and rename things. But I found this very helpful for me in my thinking, and I'll tell you why in a few minutes. I'll tell you why I'm introducing it now. So most of my formal training is in ethics and then in business, and I kind of came to the tech game a little bit later in life. I still do have some formal training, but there was a little while there I was kind of floundering on my own, trying to put the pieces together, and people would say things like, hey, for this, do we want to run a neural network algorithm or a regression algorithm? And I'd be scratching my head at sentences like that. There's just like a blobby word salad of like technical terms get all mashed together. And being a philosopher, I like clarity, right? Like these terms have to be used in specific ways. So it was like, neural networks, is that even an algorithm? Isn't that a type of model? And like a regression, regression's not an algorithm either. It's something that you want to, it's a way to learn. It's a learning task. And you know, just yesterday I used a neural network to run a regression, so I know they're not like opposed to each other, right? So I get some clarity here. So this is like how I got the clarity, or how I'm getting the clarity. So the top, the row there, is the different learning tasks. That's mostly traditional regression and classification, or supervised learning. Dimensionality, reduction, and clustering are the classic kinds of unsupervised learning, and then reinforcement learning is its own thing. I would say the only controversial thing that I did in that top is I pulled out regression, separated it from classification. And you could respond to that saying, well, regression is a type of classification. It is a classification learning task. And I don't think I could say you're wrong about that. But both from an ethical and a technical standpoint, recognition is such a different type of classification than other types of classification that I found it useful to just give it its own column there. You know, so start out with the idea of just the word, recognizing, like recognizing something that's already been cognized, now you're recognizing it, right? So a recognition task is going to be like telling the difference between a cat and a dog, or a non-cat and non-dog, or telling the difference between a 1 and a 7, or telling the difference between a sarcastic statement and a genuine statement. These are not very similar to other kinds of classification tasks where you're trying to put people, you're inventing buckets about what makes a good employee or a bad employee, and then you're putting people into those buckets. It's a different kind of thing. The ethics are different. You know, in classic classification tasks, it's like you usually have like way more rows than you do features. In recognition tasks, it's often the opposite. You have tons and tons of parameters. So it's different. Recognition tasks are almost always initialized in neural networks. Classification tasks can be done in any type of model. So anyways, if you don't like that separation, then make your own chart. Okay, and then not only do you, I mean, if you want to use machine learning, not only do you have to have a learning task, but you have to have that learning task has to be instantiated in a model. So we have what I'm calling recursive models. I might change that term at some point, but I just mean like recursive splitting. So like decision tree would be the easy example in regression classification, but even something like hierarchical clustering, I think, could be counted as recursive. Then we have neural network. Of course, I didn't invent that term. It's already a term. There are also analogical models, so models that work by finding similarities and differences in the data. I think support vector machines are a strong example there. And then probabilistic models, and that's just a description of like the Bayesian and the Bayesian-related, Bayesian-adjacent things, right? So you have to have two things to do machine learning. You have to know what your learning task is, and you have to know what type of model you're using. Okay, and then in those boxes, then we have like the actual algorithms. Okay, and I'm also not claiming that every one of these boxes is going to be filled or that they're going to be equal. You know, obviously, like the neural network recognition box is going to be very, 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 very overfilled, and some of these boxes might not have anything in them. Although things do change. Okay, so why in an ethics survey video about machine learning am I introducing this? Because both for the concepts of bias and accountability, I think the most basic thing to understand is that in each of these boxes, you have to have a different conversation about bias and a different conversation about accountability. A lot of people in articles start out with trying to make some very general statements about how to get accountability, But I don't think that you can really start there, because what it means for a Bayesian regression to be accountable is not the same thing as what it means for a neural network to recognize something. I mean, those are like, it's just, the whole conversation of accountability is going to be different. And the same thing with bias. So if you don't like this chart, that's fine. Don't be mean to me. Don't hurt my feelings. But what I'm saying is not that this is like the most accurate thing in the entire world. I'm saying that, I'm making the point that if you want to talk about algorithmic bias and algorithmic accountability, I don't think you can do it in general terms very well. Like, you have to say, okay, we're talking about this model type and this learning task. What does bias mean here? What does accountability mean in this case? All right, so that is a bit about machine learning, and I've kind of thrown in some reinforcement learning there at the end for you. But I think this is really an important part of the ethics of artificial intelligence, and as I said already, this is the area where you really need to know some technical stuff in order to really make the ethical stuff make sense. And with that chart, hopefully now you understand what I mean by that.